Happy Monday! We are actually starting Quadratics Day 6 today. Hope everybody's doing well. And today's a rainy day, so it's a perfect day to just sit back and relax with some math, with some algebra. So the first thing I want you to do is I skipped back to I had a blank paper because I wanted to go through and talk about what square roots are, because those are going to be helpful for us today. I would like to think about the first 15 or so perfect squares. So when I think about what a perfect square is, I know you've dealt with these before. I'm thinking of a number that I could have two factors that are the same whose product gives me that number. So for instance, 1 is a perfect square because the square root of 1 is 1. The next perfect square would be something where I had 2 times 2. So the square root of 4. So 4 is a perfect square because the square root of 4 is 2. Moving on to get 3, it'd be the square root of 9. So you can work backwards too. 1, 4, 9. So 4 squared is 16. So the next perfect square is 16. 5 squared is 25. So the next perfect square is 25. And so on. So if you can do the rest, the next 10, that would be awesome. I'm going to write them down. You try without me too, though. Okay, so 49, 64, 81, 100, 121, 144, 169, 196, 225. And now we can keep going, but really, if you know the first 10 per se, it'll be very, very, very helpful for this next day within our quadratics unit. In the past, we've had other numbers that we've been asked to take the square root of, and they weren't so perfect. They were not perfect squares. So some common numbers that I might have asked you, or you may have been asked by another teacher in the past, is like, what's the square root of 8? Now, 8 is not one of the perfect squares. So what we're going to do with any number that is not a perfect square is we're going to simplify it. We're going to think about what can multiply to get 8. One of the factors that I'm thinking of right now has to be a perfect square. So I'm going to think about, okay, obviously none of these bigger numbers than 8 are factors because it's something that multiplies to get 8. So then 8 would be like around here. So now I'm going to go to 4. Is 4 a factor of 8? It is. So I'm going to rewrite 8. It's kind of like the split the middle the other day. So 4 times 2 is the same thing as 8. So the square root of 4 times 2 is the same as the square root of 8. What's nice about square roots is the property tells me about square roots is that I can break this up as well. So the square root of 4 times the square root of 2 is the same thing as the square root of 8. The benefit of doing that is because something nice happens when I write the square root of 4. It is also known as just a 2. So if I'm going to break down radicals, your goal is to write down the two factors, where the first one preferably is a perfect square. And in fact, you want to get the largest perfect square. So square root of 8 can be simplified to 2 radical 2. So let's try another common one. Radical 12. So 12 is not a perfect square. It's not one that if I could take a square root of, I'm going to get a whole number, an integer. I'm going to look to see what factors of 12 there might be. Nothing's going to be above 12 as a factor. So I check. Is 9 a factor? It is not. Is 4 a factor? It is. So I'm going to rewrite 12 as the square root of 4 times 3. Square root of 4 times the square root of 3. In other words, it's 2 radical 3. So the square root of 12 is also known as 2 radical 3, or 2 times the square root of 3. Those are equivalent. So if we need to simplify radical 12, we can rewrite it as 2 radical 3. Let's just try a couple more of these. How about the square root of 20? 20 is not a perfect square, so I'm going to look to see the factors. That's why it's beneficial to be able to write all these numbers down. So nothing's going to be bigger than 25 because then it wouldn't be a factor. Factors are what you multiply to get 20, I should have said, not 25. So 16, nothing multiplies to get 20. 9, nope. 4, again, 4 seems to be a magic number today. So square root of 20 is the same thing as square root of 4 times 5, which is the same thing as square root of 4 times square root of 5, and square root of 4 is 2. So the square root of 20 simplifies to 2 radical 5. Okay, let's pick maybe one that doesn't have a 4 as a perfect square. So it's square root of 27. 27 is not a perfect square. So we'll go through the list and see if 25 is a factor. No. 16 is a factor. 27 divided by 16, no. 27 divided by 9. Ooh, 9's our larger perfect square. So we're going to rewrite radical 27 as radical 9 times 3, which is radical 9 times radical 3, or 3 radical 3. So the radical 27 is the same as 3 radical 3. Okay, let's trying to pick a good one. Let's try radical 72. Okay, so 72 is not a perfect square. Let's go through. Is 64 a factor? So when we get into more difficult ones, just so you're aware, you can check them like this. I want to know if 64 is a factor. So 72 divided by 64, does that work out? No, not so nice. 72 divided by 49. Nope, doesn't work out. 72 divided by 36. Yep, that works out. So 36 and 2 would be the same result as radical 72. The reason I chose 36 is because the square root of 36 is 2. So radical 72 reduces or simplifies to 6 radical 2. And let's try one more. Square root of 125. Finding through here, let's see, 121, 125 divided by 121, no. 125 divided by 100, no. We're going to keep going until, let's try 49. 125 divided by 49, no. 125 divided by 36, no. 125 divided by 25 is 5. So 25 times 5, square root of 25 times the square root of 5 simplifies to 5 radical 5. I'm going to suggest that if you need further help on simplifying radicals, that you take the time throughout this lesson or even before this lesson to simplify radicals. Just Google any search about simplifying radicals. I'm sure they'll have great examples on there. And we're going to now move on to day 6, coming back to that simplifying radicals as needed. So I would like you to try to simplify these 4. So simplify each radical with kind of what I just showed you and what you've known in the past. So take a minute now and pause the video and try those, and then I'll show you. Okay, so square root of 81, oh, we know that's 9. Square root of 100, oh, is 10. Square root of 144, 12. 121, 11. Okay, so these happen to be all perfect squares. Again, anytime that you are dealing with anything to do with radicals but you know you're going to simplify, I might suggest writing down at least the first 10 perfect squares. Now, these are not numbers that I definitely have memorized per se. In fact, I'll see if I missed one. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. So that's all I did in my head. I did 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. If you need to, you can use your calculator. Okay, so why I had you start with the square root is because we're gonna try a new method today instead of the zero product rule. We're gonna try something called the square root method. We use the zero product rule to find out what x could be when I was solving an equation that had to deal with a quadratic. That's with the x squared. So we're gonna use first, before we get to square root method, we're gonna think about, let's do dots, what we did before, because if you notice, we'll try these 3 with the zero product rule, just so you see the difference. Okay, so it's already equal to 0, but I need 2 factors that multiply to get that, and I noticed right away that this is a dots, so I can rewrite this expression on the left-hand side of the equation as x plus 3 and x minus 3. So these two factors will multiply to get that. Remember, because the middle term goes away, one will have to be positive, one will have to be negative, and they both need to be the same. Difference of two perfect squares. They're both perfect squares. So now with the zero product rule, I know that the first factor's got to be equal to 0 or the second factor's got to be equal to 0. Okay. So I have two solutions, two answers when I write this out. The two numbers that I could plug in right there are -3 and 3. Okay, using that zero product rule again, we first need to make it equal to 0. So even though 4 is a perfect square and we would have maybe thought to do with dots first, if you're using the zero product rule, it has to be equal to 0 first. So x squared minus 36, the beauty of this number is that that's still a perfect square. So this can be rewritten as dots. So either x plus 6 equals 0 or x minus 6 equals 0. So there are two solutions, two answers that would give this equation, keep this equation balanced. If I plug in a -6 here, that would be 36 minus 4. You get 32. If I plug in a positive 6 here, I'd have 36 minus 6, or 36 minus 4, which is still 32. So you could plug in a negative, because remember, that really would mean -6 squared. That's not the same as -6 squared. Okay, there's a big difference here. I'm asking 6 squared here, and then I'm putting a negative in front. And here I'm saying, what's -6 times -6? Okay, so be careful of that. All right, let's do number 3, using the zero product rule, just a refresher. So we first need to set this equal to 0. So it's 4x squared minus 64 equals 0. Now, if I'm to factor this, the first thing you should always do is factor out the GCF. So 4 and x squared minus 64 divided by 4 is 16. Okay, so I factored out the GCF. Then I'm still going to check DOPS, which in fact it is. Okay, so now I have 3 factors that equal 0. The zero product rule tells me one of these factors must be 0. 4 is never going to be 0. X plus 4 will be 0 when x is -4. And x minus 4 will be 0 when x is 4. So my two answers to this equation are -4 and 4. Okay, I just realized I said happy Monday at the beginning of this video, and it's actually Tuesday for you. So happy Tuesday. Okay, so back to now looking at examples 4, 5, and 6. Okay, so now what I want to do is try something that's called the square root method, because there's something really nice about being able to take the square root of a number. What's the square root of x squared? So if I take the square root of both sides, because whatever you do to one side, you have to do to the other, what's the square root of x squared? In other words, what times what will give me x squared? Well, x times x will give me x squared. And what's the square root of 9? Well, that's 3. Okay, but how come up here, wasn't that really the same question? If I add 9 to this side, x squared equals 9, it's really the same thing. How come up here I had 2 answers and only 1 right now? The thing is, when you take the square root of x squared, we always need to have 2 values. We need to have the positive value of that answer as well as the negative. So this plus or minus represents plus or minus, meaning it means the positive or the negative of that value. So there are actually 2 answers. So x is either equal to -3 or +3. Okay, you can actually write it like this or like this. So for example 5, let's use the square root method. Take the square root of both sides. X equals the square root of 36. However, whenever you use the square root method, remember that there's actually 2 numbers I can plug in for x, a positive value and a negative value, that would make this work, because a negative times a negative would give me a positive. So I need the positive and the negative value of whatever the square root of 36 is. So I need plus or minus 6. So my 2 answers are -6 and 6. You can write it like that or like that. Square root of both sides. X equals the square root of 16 plus or minus the square root of 16. So x equals plus or minus 4. That really tells me 2 answers. Or x equals -4 and +4. Okay, So whatever I have circled at the bottom, you can write it either way. Okay, now we get to 1 where it has a little bit different, only because square root of 18 is not a perfect square. So let's just write down, because they're not on this side of my paper, at least the first few perfect squares. And when I take the square root of both sides, I will have x equals, I need to remember it's plus or minus the square root of 18. That's the right answer. It really is. But you have not simplified it. So we want to make sure everything's as simplified as possible. So I want to look for, start where 18 would be, because nothing higher than that will be a factor. We think about, is 16 a factor? It is not. Is 9 a factor? It is. So we're going to rewrite the square root of 18 as square root of 9 times 2, which the square root of 9 times square root of 2 is 3 radical 2. Now the whole way, I need the positive and the negative value. So here's what this means. That, you can write it like that. Or x is negative 3 radical 2 and positive 3 radical 2. I want you to see that there are still two answers to these equations. So when you're using the zero product rule, oftentimes there was 2 answers. Now there might be 1, there might be none. But most often there are 2. And then when I use the square root method that we're starting today, there still has to be 2 answers. So the most important part about this is that when you are taking the time to take the square root of the both sides, you have to do the positive and the negative. Okay, so in the beginning of this lesson, I had us simplify some radicals in the front, okay? We want to get the perfect square first, and whatever number's left over stays underneath the radical. So for instance, if you had a 9 here, square root of 9 is 3, so that would come outside the house, outside the radical sign. So let's, in number 8, if you want to take a second to try these before I do, now would be a good time to pause. But I'm going to also review what we did in the beginning of these notes. So my first question, 72. So 72, I know that 36 times 2 is 72. So the square root of 72 can simplify to 6 radical 2. 9, the perfect square that's a factor, 27. The perfect square that's a factor is 9. Square root of 9 is 3. So this becomes 3 times the square root of 3. Now notice I skipped a step here. So you could choose to rewrite them like this, or you don't have to write them out separately. 75, 25 is the largest perfect square. So square root of 25 times the square root of 3 would be 5 radical 3. 48. 48, I can use 16. So square root of 16 times the square root of 3. 4 radical 3. And 13. 9 is not a perfect square that goes into it. 4 is not a perfect square that goes into it. So 1 is. So this one is actually already simplified. So let's just simply do a couple of these where we're taking the square root method again. So we're taking the square root of both sides, noting that one has to be positive and negative, okay? So let's break down square root of 75, which we've done up here. So x equals plus or minus 5 radical 3. And I really like when at first we write them out separate, just so you realize that there are actually 2 answers. Technically, I'm okay with you writing that answer that I've just circled, but I kind of prefer that we write it out twice just to get in the habit of knowing that there are 2 solutions. So for example, 10, square root of both sides, plus or minus whatever the square root of 48 is. Square root of 48, we already simplified. So x equals plus or minus 4 radical 3. X equals negative 4 radical 3, as well as positive 4 radical 3. Okay, and example 11. In order to do the square root method, we want to get that x squared alone, as opposed to when we use the zero product rule, we want it a 0. So I want to take the time actually to move this number over to the right-hand side. So plus 13. So x squared equals 13. Now it's set up for that square root method. Take the square root of both sides. X equals plus or minus the square root of 13. We've already discovered that square root of 13 cannot be simplified. So we can write it as negative square root of 13 and positive square root of 13. Those are our 2 answers. Okay? All right. So tonight's homework is day 6, Quadratics day 6. Definitely recommend those. Writing out at least the first 15 perfect squares. When you're taking the square root of both sides, remember that you have to have a positive value and a negative value. Technically, I did not give you the direction beforehand of which way to solve, so you could have done it this way, but I am asking you to do it by using the square root method. So that means I want the x squared by itself, and then you're taking the square root of both sides. Okay? Simplify in radical form when appropriate. These are going to be nice numbers. I want you to continue on the back, noting that I want you to try with the square root method. So the first thing you're going to have to do is move those numbers over. I know that it's going to have to be x squared equals a number. So you'll have to move that 49 over. 125 is already there. You have to move the 18 over. Have to move the 50 over. Have to move the 17 over. Okay? So be careful of those and have a great day.